Hi, I'm Paul Battaglia, and this is section 1.1. I'm joined today by Gabe and Brittany. Thanks for being here.
Thanks for having me.
Happy to be here.
And you know, one of the things we're going to talk about today is the role and importance of slope in a linear equation. So I know one of the ways I like to start off the class with my students is just a quick little analogy to skiing. It's not perfect, but I think it does the job. You know, really we have 4 categories of slopes, right? So I tell students, you know, look, we could ski cross country, which might involve up, down, or even horizontally at some point. And so if we ski upward, we have that positive slope. Negative slope when we go downward. And then of course, those times when we're just horizontal, we have a 0 slope because there's no rise, right? But then that leaves that one category of undefined slope, right? And I say typically, you know, we don't see many people skiing vertically. So I find it to be a pretty helpful analogy. And then this allows me to go into the equations of lines. So Gabe, can you talk to us a little bit about the equations of lines we want students to look for?
Okay. So the big 2 equations of lines that we normally see would be the slope-intercept form of a line and the point-slope form of a line. Now, I think more often than not, we want to work with the slope-intercept form of a line. And the reason we like working with the slope-intercept form of a line is it's easy to go from the equation to the graph and to go from the graph to the equation. But the point-slope form of a line is also pretty useful to work with. And that's because maybe in calculus, when you're trying to find an equation of a tangent line, you'll know the point the line passes through, and you'll know the slope of the line. And if you know how to use the point-slope form of a line, you can go ahead, write down the equation. And if you want, it's pretty easy to take that form to the slope-intercept form.
Right, and I think, you know, sometimes too often students think that if this is the form I have to put the, you know, this problem in, that's the only form that exists in that space and time. And obviously that's not true, right? So that leads us to the investigation of parallel and perpendicular lines. And I know, Brittany, you have a really neat thing you do with graphing calculators, right?
So I will have the students, I'll show them a parallel lines on a graphing calculator and perpendicular lines on a graphing calculator. But the thing is that when I have them zoom out, each of them actually is in parallel and the other one is in perpendicular. So they were assuming going in, right? Yeah,
okay.
Just by eyeballing it, they are assuming that. But so I say, well, what can we do to actually numerically or analytically see, you know, if the lines are perpendicular or parallel? So I will give them each equations and then have them compare them, and then they'll realize that the slopes are what they want to be looking at.
And I think that that's important is you know, that conceptual idea of, you know, when we look at things that are more intricate in math, we want to have a reason for doing what we're doing, right? We don't want to eyeball them and make assumptions and things of that nature. So, you know, now we've talked about slope in its analytical form, and then naturally we like to bring in some real world stuff for the students, right? And so now we talk about slope in context. So Gabe, talk a little bit about what's so important for students to recognize there.
So students usually have some sort of understanding of slope. They think about it as rise over run, but maybe from there they go into the change in the y values over the change in the x values. But once we start working in these real life applications, maybe they want to start thinking about slope as price per unit or gallons per minute. They want to be able to think about the units that go along with the slope and not just as it rise over run, maybe. Yeah,
and I think that's so important because, you know, when we do a problem or some type of an application, now they're so inclined to just leave their answer as, you know, -7. When in reality, we need more from them, right? We need them to specify units and say -7, you know, dollars per hour or whatever it might be. You know, I hope these tips have been helpful and you find much success in section 1.1.